Hello all, welcome to AI Educator. In this video, let us learn how to create a ANN regression model. Let us consider the linear equation y is equals to mx plus c and let us assign m is equals to 2 and c is equals to 1. Remember this, we will use it again. First, let us import the required libraries. Now, I'm importing NumPy and giving it an alias as np. Next, from tensorflow.keras, I'm importing sequential. From tensorflow.keras.layers, I'm importing tens. Now let me run this cell. Yeah, they all got imported. Now let us load the data. So I'm taking an array x is equals to np.array and inside this I'm taking values from -1, 0, 1, 2, 3 and 4 and I'm assigning a d type is equals to float. Now I'm taking another array y is equals to np.array of it has a values from -1, 1, 3, 5, 7, 9 and I'm assigning a d type as float. Now for the x values -1, 0, 1, 2, 3, 4, if we apply them in the y is equals to mx plus c equation where m is equals to 2 and c is equals to 1, you will get the y values as -1, 1, 3, 5, 7 and 9 respectively. Okay, now let me run this cell and now let us build the model. To build the model, all you need to write is model is equals to sequential and a parenthesis. Now I'm adding a dense layer to the model. To add the dense layer, all you need to write is model dot add inside a parenthesis dense, and inside the dense, first you need to give how many number of nodes that you want. I'm taking only one node and I'm giving the input shape as 1 comma because I have the data in one dimensional array, so I'm giving the input shape as 1 comma. Now I'm taking a kernel regularizer as L2 and I'm taking an activation function as linear by writing activation is equals to linear. Since we have a very small data, I'm just creating a model with a single layer and a single node. Okay, now let me run this cell. My model was created. Now let us compile the model. In order to compile the model, all you need to write is model.compile and inside a parenthesis loss is equals to MSE, which is the mean squared error, and I'm giving an optimizer as SGD. Now let me run this cell. My model is compiled. Now let us train the model. In order to train the model, all you need to write is model.fit inside a parenthesis the x and y values, and I'm giving epochs is 100. I want to train my model for 100 epochs. Now let us run this cell. Here you can see since we have not given any evaluation parameter in compile, so we only got the loss. And we can see the model got trained with multiple epochs, and we can observe at the last epoch we got a loss of 0.0645, okay, which is a very less loss. Now let us try to make a prediction. In order to make a prediction, all you need to write is model.predict. I'm just assigning a variable a is equals to model.predict, and inside it I'm giving 5. So if you take this as an x in the y is equals to mx plus c equation where m is equals to 2 and c is equals to 1, we get 5 into 2 is 10 plus 1, which is 11. So if this is the x value, then we should get a predicted value as 11. So let me run this cell and let me print the a and see what our model has predicted. Let me run this cell. The model has predicted it as the 11.101, which is approximately equals to 11. So our model is predicting good. So this is the way how you create ANN regression model. So this is the end of regression chapter. See you all again in the iris case study.